Hello guys, so today we're going to do the first part of applications of the series in C cousins. We actually did the applications when we did the exponential and logarithms, when I had you all together. It's the growth and decay that are part of this, but the other thing that's not part of this is compounded interest. So let's talk about that. The first thing I want to talk about that is not in the IB curriculum is known as simple interest. And let's see, simple interest is interest earned on the original amount. So, for example, the original amount, we can also call the original amount the principal. But the idea is if you put $1,000 in the bank or you take a $1,000 loan with simple interest, so let's say a loan or a deposit of $1,000 at a simple rate of 8%, that means that either the loan or your bank only grows $80 every period. We're going to start off with an interest period of 1 year per annum, right? And so after the initial, which we're going to call P, is 1,000, and then after 1 year, you get 1,000 plus 80, or your loan is increased to another 1,080. Right? What happens after the second year? After the second year, either you gain another 80, or your loan is increased by 80. So once again, this is simple interest. It's not in the IB curriculum, but it's a way to start. So 80, 80, 80. We could say the amount in the account after n years is 1,000 plus 80n. But let's generalize it. Let's generalize for a formula. Let's generalize. So if the initial amount is P, right, and the rate is R, what do we have here? The final amount. The final amount is P plus P times the rate times R. Once again, I start with my original amount. I'm taking the rate of the initial amount, so that was 8% of 1,000, which was 80, and I did that n times. So after the first year, I had 1,080. After 2 years, I had 1,160. After the third year, I would have 1,240, and so on and so forth. So let's look at the first example on the sheet. Sebastian took out a loan for a new car that cost $35,000. The bank offered him 2.5% per annum, simple interest for 5 years. Calculate the total value Sebastian has to repay the bank. The first thing you want to do is underline the word simple interest. And so we can take a look at this and say, okay, we're starting out with $35,000, right? I know that each year it's 2.5%. Know how to do your decimals. Know how to convert percentages into decimals. I know that each year it's growing at 2.5% of 35,000, and I'm told that it's 5 years times 5, which means my Sebastian's loan after 5 years is $39,375. Good. Let's continue. Now let's talk about something. I believe we spoke about it earlier in the year when I had you connect together with the higher level kids. So I'm erasing. the next idea is compound interest. Compound interest. And once again, in both cases, either you've put money in the bank or you've taken a loan. Either way, the percentage of interest is now based on the current amount. So interest owed or earned on the current amount. And we've done, let's take the last example that we did, but we're going to grow the rate at 8% per annum, and it's going to be compounded. So we start off with $1,000. The rate is 0.08 or 8%. It's per annum, once a year, and it's compounded. So the initial is 1,000. What happens after 1 year? What happens? What's the final amount after 1 year? You say, okay, well, it's 1,000 plus 8% of that. Well, you kind of look at a formula like, wait a minute, I can factor out that 1,000, Mr. Adler, and I'm left with 1.08. And so the final amount here, it's originally 1080. You're like, well, it's the same thing. But let's take a look what happens after the second year. After the second year, I'm taking my 1080, right? And I'm doing 8% of that. That's the change, right? That's the change. That's what's going on here. So I can factor out, what can I do? Well, we know, let's just mathematically, so if I pull in 1080 here, I have, I have 1 plus 0.08, but over here when we factored out the 1080, we said that was also 1,000 times 1 plus 0.08. And so if you actually recall, the formula is it's 1,000 times 1.08 squared, right? And so to figure out the third year, how much interest, it's 1,000 times 1.08 to the third power. Now, what were the numbers here? Let's see, after the second year, it's 1166. And then after the third year, it's 1259.71. Now, in the simple interest, it was really easy to figure out how much interest you were getting each year because you knew it was 80, 80, 80, 80. You can kind of see what's going on here. You know, you can see this is plus 80. What's going on here? This is plus 86. What's going on here? This is plus 93.71. It's not really important, but you can see I just subtracted. You go, oh, you gain, 1259.71 minus 1166. Oh, it increased by 93.71. That's not really important. And yeah, that's the idea. So we know the formula. We kind of have the sense of formula. It's 1,000, right? So a general formula would be A, which is the final amount, equals P times 1 plus the rate. I'm going to put the rate. We know to write this as a decimal, okay? Times N. So the A is the final amount. The P is the initial. The R is the rate. I'm sorry, let's make this, instead of N, I apologize. We're going to make this T for the time. Okay, but you're not going to see that formula in the formula booklet. You're going to see something a little bit different. We're going to introduce time periods. And I'll do this in what color should I use? I'm back in my room. Ooh, I got lots of colors here. Let's see if I can have pink. Let's see, we're going to introduce time periods. And so I'm going to put that down here and up here. So I'm going to divide the r by n, and I'm going to multiply the t by an n also. You'll see this in the formula book. This is the idea of time periods. Sometimes your money is compounded annually. So that's n equals 1, or 1 times year, but we can also do other types of compounding. Other types of compounding that you need to know about is quarterly and monthly. Quarterly, which is n equals 4, and monthly, which is n equals 12. Now, you might remember when I still had you with the HL kids, we compounded it an infinite number of times, and that's where we got E from, but don't worry about it. We're on a different track. IB doesn't even get to this till like a couple of units, so we're fine just with these 4. Well, okay. So let's just jump right into some problems, because the idea is you have all these variables, and obviously in the question, you're going to be given all these variables. How are we doing for time? Perfect. And you're going to be missing one. Okay, so question number 2. I'm erasing. Question number 2. Habib put $5,000 into a savings account that pays 4% interest per annum, compounded monthly. How much will be in the account after 4 years if Habib does not deposit or withdraw any money? Fine. So, first of all, compounded monthly, it's a compounded, you're using that formula out of the formula booklet. Can you see that? Yeah. Next, let's get some information. Habib put $5,000, P equals 5,000. Into a savings account that pays 4% interest per annum, R equals 0.04, compounded monthly, N equals 12. How much will the account be after how much will the account be? So A is unknown. After 4 years, T equals 4. If Habib does not deposit or withdraw any money. Okay. So we know that A equals 5,000, open parentheses, 1 plus 0.04 divided by 12. What's going on up here? Well, the formula says, well, if we're doing something 12 times a year over 4 years, we have it 48 times. Figure how to get this in the calculator. This one is just a regular basic arithmetic on the main screen. The final answer is 39,375. Now, question number 3. This one is about Leslie. Leslie got a student loan of $12,090 to pay her tuition at the University of Toronto. It's Toronto, it should be Canadian dollars, but whatever. If Leslie has to pay $16,000 in 2 years, what is the annual interest rate if the interest on the loan is compounded monthly? So once again, you underline the word compounded, you're using that formula. Let's see what information is given. Leslie got a student loan of $12,000. She originally got $12,090. If she has to pay $16,000 in 2 years, okay, so after 2 years, the final amount is $16,000. What is the annual interest rate? R is unknown. If the interest is compounded monthly, write this down. You're getting a method point just for writing this down, right? And then you're getting another point for substituting those numbers in the formula. If you have absolutely no clue, but you kind of know it's the formula, write some numbers down and stick them in the formula. You're still getting points. Okay, let's get this down. 16,000 is equal to 12,090. Open parentheses, 1 plus R over 12 raised. Once again, we're doing something 12 times a year over 2 years, 24. Final answer, R equals, we're looking for the rate. So just make sure you know what answer you're looking for. I put it in my calculator. Because this is an equation, there's two answers. One of the answers is negative 24. The other answer is 0.141 or 14%. Use common sense. The rate is not negative 24. If you can't figure this out in your calculator, please tell me. We have to get you perfectly on that calculator. Once again, these are crazy numbers. This is not a part 1 question. So you get a calculator, so we need to make sure that you know how to use it. Number 4, last question. Oliver's saving account has a balance of $900. If the interest rate was 1.5 per annum, compounded quarterly, how much did Oliver originally deposit 6 years ago if he has not withdrawn or deposited any money since? Okay, so we want to figure out what happened in the past. So obviously P is unknown. They might try to trick you with this time thing, but remember, okay, now is my final amount based on what was in the past. So it now has a balance of $900. The interest rate was 0.015 per annum, compounded quarterly. How much did Oliver originally deposit 6 years ago? Okay, once again, get this down. That's a point. That's a point. And you can see, I'm going to rip this off the wall right now. These are the ranges for the higher level kids. And you can see, you need that 1 point. The difference between a 74 and a 75, the difference between a 49 and a 50, that's a 4 and a 5. So don't, oh, I don't know what to do, and put nothing down. No, put stuff down on the paper so you can get some points. Let's put this together. 900 is equal to P, open parentheses, 1 plus 0.15 over 4, because it's quarterly, right? Raised, so let's see, it happens 4 times a year. 6 times is 24. Final answer, P, the original amount was $822.68. Please know how to put this in your calculator. I know that my kids know how to do this. It's M-Solver. What is it? Yeah, you go to menu, right? Menu. Is my computer on? Yeah. You go to menu. And then the first thing is go to algebra. And then the first, on my calculator says solve, but you should have something called M-Solve. And then you're going to put this whole thing, you're going to have M-Solve. You're going to put this whole thing in parentheses, but make sure you do comma, whatever the variable is. And you should get that number. Once again, please tell me if you're having trouble with the calculator. Thank you. I'll put the homework up.